What we're hoping to do today, I get to do the light lifting. I'm going to just help John introduce asset management as we think of it. Over this series of workshops, lunch and learns, what we're going to do is actually bring some other folks, so you're not listening to John and I every time, but we actually have other folks. I'm trying to think if any are sitting in this room right now, but we'll come and talk because, as I said, a lot of us are doing asset management now. We just maybe didn't call it that. So in basic terms, some of the main principles that we want to talk about are, as a public works director, I manage tons and tons and tons of records. You can imagine in any town or city, particularly in New England, that has been around for literally hundreds of years, there are documents. And it doesn't matter how long you've been there, people expect you to know exactly where every document is, to know where everything in the ground is, to know where all your record drawings are. You maintain buildings and vehicles and infrastructure, whatever it is. So every community does asset management. They may just not call it that. They might have a whole bunch of paper records. They might have scribblings on the back of a napkin or an envelope that they threw in a file drawer somewhere. So everybody has some method that they're maintaining their assets now. Everybody has some level of an inventory. And what an asset management program does, which is what we're talking about, it's a cyclical. That's why you're going to see this a lot. In a lot of the slides today we're talking, you'll see it's very cyclical. So the basic points of any generation of asset management, you have your inventory. The term I hear, a lot of people using around here is GIS. For a whole bunch of people, I do GIS, aviation. I'm locating assets in the field and putting them in a GIS layer. That's asset management, digital asset management. When you really get going, you want to start assessing the condition of all of the assets you're tracking. Everything we have, whether it's a computer, a pencil, a truck, a building, they have a limited life. They're in some varying state of decay. So an assessment of condition, how do you maintain that? What are your maintenance records? What do you know about the asset? What do you want to do to maintain it? And I'll use the word asset loosely. Because like I said, it could be a pencil, it could be a building, it could be a pump, it could be a pipe. An asset can be any physical thing. What is the life of that? What do you expect the life to be? That's important when you're talking about the cost. Most communities live in a low bid world, but if you can demonstrate that, maybe buying that next expensive piece of equipment or the next expensive thing, in the long run will save you money. So all the cost of operating, maintaining, and owning and disposing of that asset at the end of its useful life, if you can get it, it's great to know. The level of service, what do you expect your assets to do? How are you going to use these assets? What do you expect from them? So that's something we can define and build into the model. What is the criticality of the asset? That's a big word that means if it's the road leading to the hospital, it's probably more important than a dead-end subdivision that goes to 4 houses. If it's the main trunk line that takes sewage from the whole town down to the treatment plant, probably more critical than the one servicing 4 houses. So some rating of how critical that asset is to your overall system. It's all about, everything leading up to here is all about helping you optimize how you plan and maintain those assets. How are you going to properly fund? And in my years of experience, if you walk in, budget committees are really smart. And if you just walk in and say, hey, I've got a 10-year plan and this thing's up, so I need $500,000 to replace it, you're probably not going to have much luck. But if you walk in with a whole service history and this is how the thing's been degrading and it's getting close to its failure point, this is how critical it is, they're going to give you the money every time. Because at the end of the day, they have to service the public. The reason it's a cycle is after you've gone through this whole agonizing thing, it's always morphing. You're always getting better data. You're replacing old assets with new assets. Once you get the system set up, when you buy that new asset, Now you know the purchase cost. You know the life expectancy. Over its life, you're going to track how it performed. You want to get to the point where you start to look at, should I buy an international truck or should I buy a Mack truck? Should I do a steel beam bridge, or should I do a concrete beam bridge? Once you get enough data, those decisions start to get easier to make based on the data. Why is it important for Hoyle Tanner to get into the asset management business? It's a requirement. More and more and more, we're seeing it as a requirement. If the federal government is going to hand any community money for their sewer system or to upgrade their wastewater plant, the federal government wants to know, are you managing your asset okay? You know, do you have a plan? Are you keeping things up to date? Are you properly funding it? So all of these organizations and more, you know, EPA, all the new permits coming out, there are CMOM requirements. CMOM is just another word for you have a maintenance plan for all your assets. The new NPDES stormwater permits, they want to know the communities are having everything mapped. They want to know that you're keeping track. The performance measure for cleaning catch basins is no longer we want you to do it every year. It's now when the sump is half full of sediment. We want you to guarantee that you're going to clean that catch basin no less than when the sump is half full of sediment. How's the community supposed to track that if they don't have some kind of system that they can real-time manage how they're doing? What different states have been doing in New Hampshire? EES is giving out asset management grants, loan forgiveness on an SRF. We think Mass is going to do the same thing. Rhode Island has requirements. Maine, actually Maine is doing the same as New Hampshire. Which one is the straight up grant? Isn't there one that's just a...
Well, Maine has forgiveness on principal loan, and basically New Hampshire and Mass it's a loan with 100% forgiveness. So, but it's not a grant.
Is the different states have a slightly different way of packaging. The point is, they're all encouraging. They're trying to encourage water and sewer and stormwater to implement. Highway, FAA. You know, I haven't dug into the details before I understand. The FAA has requirements. We do a project now. They want to see. They want everything mapped, handed to digitally, with attributes assigned to the different things that you're building. That is all asset management.
Okay.
What is principal forgiveness?
An SRF is a loan. I personally hate that. But what the way DES does it is, you go take out a loan, and when it comes time to pay the loan back, we'll forgive that you owe us the money. So it's
Pretty much what it sounds like.
yeah. The problem is you still got to treat it like you're really getting a loan. So there's all kinds of approvals and votes. But it started out, I think they used to do a P, like 10% principal forgiveness, but in this case, it's 100% principal forgiveness. So what are the drivers? What are the challenges? In New England particularly, we have extremely old infrastructure. We still have pipes in service. I see a wooden water main on the hall out here. You know, I was in Dover when we pulled the last piece of wooden water main out of the street. I actually was working at that time. So our communities in New England are very old. The infrastructure is very old. However, we also have very limited resources. There's not enough people to maintain what we have. The age of the average municipal employee, like wastewater treatment plant operators, the average age of a wastewater treatment plant operator in New Hampshire is something like 57 or 58 years old. So in the next 5 to 10 years, there's going to be an enormous brain drain of all these people that have run these systems for years and years and years. And how do you communicate all those little maintenance tricks that everybody knows to keep a system running over the decades? How do you communicate that to the next generation coming in that still has to make compliance with these systems? The boards, committees, councils, elected folks that make the decisions on how much to fund this are also ever changing. The nice dynamic that I always had to deal with, and I used to call it the Washington effect. Everything you see getting messed up in Washington, people get really mad about it, but they can't go yell at Washington. They can't yell at Congress. They yell at the local officials that have to decide how much to budget to take care of assets. So there's the decision makers are a problem. Every aspect of the budget is being squeezed. Fire trucks are more expensive. Police can't get what they need. The schools always need more money. So there's never enough money. And in today's world, I call it the McDonald's factor. Everybody expects immediate satisfaction. The minute they push the button, they want the answer right on the screen of their phone at any given time of day. That's just what our society has become accustomed to. So getting the information you need at your fingertips is key to all of this. As we evolve, technology changes. We're always going to be in this race to keep up with technology, and the regulatory environment always changes. So having a good grasp on what you have and what you're trying to maintain and how you're going to maintain it is critical to keeping up with those aspects. So who is involved? Who are the stakeholders in all of this? It's everybody. I've mentioned a bunch, the decision makers, the management of whatever agency you're talking about has to buy in. They have to be comfortable with it. The folks in the field, if they're not going to do it, you don't have an asset management system. So getting the folks that are actually going to be touching the data, actually going to be collecting it, they're the most important ones of all. Because if they're not going to actually collect it, then you don't have it. All of the operations personnel, are they really going to use what you tell them? Are you going to give them something they're going to see that has value? You need to get them involved early, get their buy-in. And of course, in any of these systems, and John can give you war story after war story after war story, the problem with asset management as a consultant and as we deliver it is every client is going to be different. Every client has a unique IT setup. Every client has unique technical abilities, expertise. So you literally walk in to any client, and the only thing you can be assured of is going to be different than anything you've ever seen. That's just the nature of the IT world that asset management has to live in. And then there are all kinds of third parties. Every whether it's a community or an airport, they have a software package that collects this data for them. They have a software that does this. They've got stuff in spreadsheets. So you got all these third-party entities that have to be able to talk with and get information into and out of whatever asset management system you're going to employ. And then, of course, all of it has to be, especially if you're in a public agency, it all has to be transparent. It all has to be above board. So the public is heavily involved. And as with anything, change comes hard at every one of these levels. This is another cycle. So the first steps, what are the needs? What is the vision? What are you hoping to accomplish? Some communities will never get beyond GIS maps. That's what they want. It's all they can handle. That's the end of it. You help them get really nice GIS maps. But what is really important for us as a consultant is someday they may decide, and a certain fraction of them will decide, they want to go to that next level. I've got my maps, it's great, but you know what? I really still want to start looking at the condition. I want to start considering the criticality. I want to start building the system up. The worst thing we can do at that point is say, oh, well, you should have told me that in day one because we set up the data all wrong, and now we have to redo it. So what's important for us as we're implementing whatever asset management we're talking about, always have the eye to the future. Advise the client that, you know what, we want to set you up. Even though you only want to do mapping, let's define the fields this way. Let's set up these fields you're going to need, because if you go to the next step, you're going to want this later. So let's do it now. And I guarantee you they'll be happy you brought it up. Where do we need to focus the effort? Again, everybody is different. Every client is going to have a different goal. Some things are gonna be what they consider low-hanging fruit, based on, maybe they got a really big water budget. That's where they wanna focus. Maybe they had a bridge fall down. Whoa, that's what we wanna fix, that's what we're gonna concentrate on. So, where is the biggest return? Risk. People used to ask me, what was my job description as public works director? And the number one job description, I manage risk. That's my job. Whether the risk is people, whether the risk was assets, I reacted to whatever exposed the most risk. That was the priority of the day. So what are the where is the exposure, and what do we need to get done? What, you know, you got to have your priority of what's. Oftentimes it's what can I sell first? What can I? And I say that from a municipal perspective, like what's going to be the easiest sell to get the project going, and then we'll bring in the less sexy stuff later. Once you've gotten there and now you're in asset management mode, you're going to start to refine it. You're going to start to see. I remember when we first started doing GIS, so many people are going, oh, I don't need that. I know where everything is. I look at paper maps. They're great. We just added MyLars redone. Once you've gotten into GIS, you'll never even think about looking at a MyLar again. So then you start thinking of the next level, the next step. How do you keep going? And then you're assessing the effectiveness. Did I do a good job? Do we like that? Did the data work? Did the field guys actually use it? If not, you're going to tweak it. And you start all over again. And you keep going around and around. Each trip around the wheel, you're getting better and better and better at managing, delivering, knowing what to feed in, what questions to ask. So what does an asset look like? I just got a couple more. It's anything. It's this permit. It's these signs. It's this crosswalk, this hydrant. Maybe even that cone. You know, the wastewater treatment plant, almost every physical component of the wastewater treatment plant has a maintenance schedule, has a manufacturer, has a life expectancy. Wouldn't it be great if it's all on one computer and you can generate all your repair orders and your work orders from that one system, so you know when a pump will start to show signs that maybe we want to start thinking about replacing this pump. Obviously, big water tanks. One more slide of some others. I'll wander this way because John's taking over.
Yep.
You know, the culvert, the MPDES permit. There are so many aspects that are important. One is the obvious condition of the pipe, but there are also, is there a flow restriction? Is that a risk for washing out the road in the 100-year storm? Is the outfall perched? Because if it is, you might be able to get funding to fix it from other sources. If you're measuring the quality of the water coming out of that and tag it to the end of that pipe, and then you start seeing water quality issues popping up in your database. You have a map to show these, that's where it is. Obviously bridges, paving, what kind of paving is it? How thick? You know, what are the sampling results? In an asset management world, all of that data is linked graphically to the GIS map. So when you get done paving that street, you get test results. When they look at the GIS map of that street, they can just pop the folder open, and all the test results when the asphalt was put down can be right there. Any complaints? What kind of striping did you put? You know, any details associated with that job can be linked right to that asset graphically. And then as work complaints come in later, they had a pothole on such and such a street, that gets linked to that same line segment. And so on and so on. It's that whole cycle of better information, better management, more refined results. So at this point, I'll turn it over to John and we can start talking about the heavy lifting part.
Thank you, Kyle. You've almost worn through that key.
Yeah, I know. I know. Okay, we're going to start off with condition assessment. And condition assessment, you use it in every single one of your disciplines that we have here. And you know, condition is developing a standardization. So if you look at something structurally, you have to look to see what defects am I measuring on that. You know, so if it's a pavement, you're looking at cracks, you're looking at you know, sags, rutting, and everything else. If you're looking at a bridge, I don't know what you look at. Aaron, what do you look at on a bridge?
Corrosion, section loss, condition of deck, concrete
Yep.
deck.
And do you break it out, you super deck,
Yeah,
different
structure,
sections?
structure.
And then each have their own defects?
Yeah.
Yep. So, and then it could be a pipe, and Ben's not here, but they have all the different defects that go in. They're all standardized, and that, you have to be certified because the condition assessment is a standard process. Developing the standards, but there's a lot of things that don't have standards, like sidewalks. And a lot of times you look at different standards, is it handicap accessible, is there poles in the way? You can kind of break things out, but there isn't really a standard yet out there. We're looking at other things, hydrants, there's no standard. But everyone knows, that's a good hydrant, bad hydrant. That's kind of an inspection more than a condition, and I'll go through the difference. Then operational, is it maintained? And is the history? What's the cost of maintaining it? And have you had to maintain it greater than what the manufacturer's recommendation because it seems to be deteriorating? And then the history. Did you buy a lemon? Are you spending more for that asset than it should be? We just purchased 3 generators in Newfield, and 2 years and 3 months after we purchased a brand new generator, it blew apart. So that's kind of a lemon. And of course, it's 3 months after the warranty, so we own it. But to kind of put this in a little perspective is, it would be like you're going to a doctor's appointment, and the doctor all of a sudden looks at you and, he's saying, oh, geez, I see you have got things growing on you. Well, he makes that note down. So he's going through and he's measuring all the defects on your body. That's the physical defects, and he has standards, what's acceptable. And then operational. Well, Johnny, you been going to the gym? Oh, yeah. Well, have you been going 3 times? Well, not, okay. So he writes that down, and of course, then all of a sudden he says, what have you been eating? Oh, pizza? Okay, how much coffee you had? And then he looks at the historic. And I love the historic. So what did you do in the 60s? Okay. They don't ask you if you smoke anymore. Now, most of you guys were born parents that were in the 60s. It does lag on,
I'm with you.
Okay, but, so the doctor does the kind of the condition assessment, but it's not really the condition number that you want. All of a sudden you go to get your life insurance. That's a different policy, They look at all those records, and then they say, well, are we going to insure this guy? What are they trying to figure out? They're going to find out what the end of your useful life is. So they're looking at that point. Well, can we collect a premium long enough before he crashes off? Well, that's what condition assessment is. It's giving you that number. When you do a PCI for a pavement, it gives you a number on the deterioration curve. And that's all the insurance is trying to find a number. So when we go through and here's a physical condition board, and we look and we're looking at corrosion on the surface, structural, there's different things that are operational. Surface rubber is operational. You didn't maintain it. You didn't paint it. Get to it before it rusts apart. And then, does it have leaky gaskets? Those are structural. So, at what point is it acceptable? Vibrations, they're indicators. Meaning the worse the vibration, less likely it's going to live and it's going to move out on the structure. Then you look at the concrete pad that's on or anything else. So this list can be quite detailed. If we had a roof one, the roof one that I have is close to 2 pages. You're looking at drainage, drip edges, everything. So it's all detailed. You break out the different asset parts and then you rate them. Then you develop that standard. So that's what the insurance company does. They come up with a number. Here, we come up with a number for the physical condition. Now, having one point on a deterioration curve tells you what? Not much. Okay? That's why it's so important to standardize it. So if it's done 5 years from now, you start connecting the dots, and you're trying to find out where it's going to start failing. And that's one of the things when you look at pipelines. A lot of pipes have a lot of defects. You know, structurally it's in rough shape, but the fact is, you look at it 10 years later, it hasn't gotten any worse. You know, it's just like Chris, you know, he's always looked old, you know, and he'll probably live forever, you know. But that's what we're looking at. Where do we develop that curve? And why is that important as engineers, designers? You want to understand what these condition ratings are so you can design an asset that has the longest and flattest curve to keep its useful life. So if you know that you've designed something and you do bridge inspections and you know what's deteriorating, maybe when you design a new bridge, you can start addressing those critical aspects. But at the same time, you're understanding what the client is facing. So again, the more you understand about condition assessment, the better off you're going to be as an engineer.
John, just one question. The scoring system on the previous slide,
Yeah.
is that an industry standard that you guys work from, or is that something that's developed?
We developed each one based on the client's needs. There are industrial standards for pipe, bridges, and stuff,
On a
manholes.
scale of 1 to
but-
5? Or?
Right.
Mhm.
And like we're going to be doing training Thursday in Portsmouth. And well, actually, it's probably a couple weeks we'll be doing condition. And we talked about condition assessment. Do we want it as a deduct condition? So you start off at 100. And every time you find a defect, you're deducting from 100. It's like the PCI. So if you have pavement, brand new pavement, you start off at 100 and then you go down. Okay? Now, that's one way of doing condition assessment. Another way of condition assessment is the PACP, where it's cumulative. So 1 is good, but as you add in defects, it goes up to 5, and 5 is failure. So you develop what your standards are going to be. And then you also want to know who is doing that condition assessment. You know, is it Sean going out there and this is what he does all the time, and he can go through and get a real detailed information. Or you're training the guy that goes out there periodically. So he might just say, just give me a 1 to 5. I'm going to look at that hydrant, and if it looks good, I've tested it out, I'm going to give it a 3. And I know what a real bad one is. But I don't want him any more than a 1 to 5 rating. So again, you have to know your client. You got to figure out what they're going to establish, and a lot of times they just want to see the number. They don't want to measure defects or anything else. And you just give them pictures of 5 hydrants. There's a 1, 2, 3, 4, 5, and they look and say, okay, 3, 5. You know. So yeah, that's one of the things that we have to. Okay. Well, maintenance program, you know, scheduling. This is like Delta. You know, in a small package here, you know. You figure out what your program is, you know, you look at your schedule, what you're going to do, and that's really when you get an asset, you know, what does it need during its life cycle, what's required, what do you need for that routine maintenance to get out there. So again, we're saying, well, you know, Johnny, if he goes to the gym three times a week and gets his 130 minutes of exercise in a week, you know, he's going to live longer than, you know, his twin brother that eats pizzas and enjoys baseball. Nothing personal, John. But, yeah, and then when you've done the schedule, you know, how much time do I have? What do I need? I need time in my schedule to do this work. Then what do I need for equipment, resources to do my work? So even though once you've got the schedule and you've done your work order, then you have to look and make sure that you have adequate labor. When we did the projects in South Burlington, we put in all the different tasks and schedules and routines that was needed for their new treatment plant in the asset management program. when he printed that up and looked, he had close to 200 work orders that he had to do with that first week. And his response was, this program failed. Done. You know, and that's what he tells us after we've done all this work. And we said, why? And we said, I can't do it. I don't have the time, I don't have the resources, I can't do the work. And we said, well, what can you do? You know, and that always goes over great. And he just said, nothing. You know, he can't tell you what he can do. So we said, well, we broke out all these work orders based on criticality, priority, and everything else. So let's do the higher, you know, there's a scale of 1 to 5. Let's do the top 2 levels and see how many. Boom, went down to 20 work orders. And he looked and he said, oh, great. He was able to do the 20 work orders. And those were the most critical work orders on the most critical pieces of equipment. Okay? What happens with the other ones? Basically, the normal routine for maintenance people is they only put in the maintenance they can do. They don't keep track of what they can't do. But in this particular asset management program, we tracked what they couldn't do as well. And we also explained it to his public works director. He said, that's great, because now I know that if I hired another maintenance person, that there was a lot of things and there's a benefit in hiring that person. So tracking what you don't do is also critical. So that's part of it, you know, setting it up. When you get out there and do maintenance, when you do maintenance, look at the condition, because what they found was when they went out there, some of the equipment was losing oil. So that pass became more frequent. So they increased the frequency base. So they couldn't stay on the original schedule. The schedule had to increase because there was a need. Then they found other equipment that just flatlined. They said, well, we don't need to check it once a week. We're going to check it once every 2 weeks. So they're able to now reprioritize their work, what they do, and their resources. And that's the goal, is to utilize this maintenance program to do that. Okay. This is the slide all about me, you know. Okay, and this is really, it's all about the asset. You know, everything is asset-centric, okay? That means all the information that you need to know about that asset is critical. You know, you need to know the maintenance on the asset. You need to know the condition of the asset. You need to know what that asset does. How critical is it? Is it critical if it fails financially? Is it critical if it causes environmental issue? Is it critical because it may cause social or lower level of service to clients? So what is the asset? And value. Every asset has a value. You know, so you have to develop what that value is. Because what you're trying to do is collect information about each and every asset. Life cycle cost. Okay? Okay. Basically, when, as engineers, we kind of spec out and we say, okay, this is what the capital investment is. We tell the client, this is what it's going to cost to do the project. And then we kind of like, after the project's built, we kind of walk away. And they look and say, okay, I built the bridge, and I think for Rochester, they asked about the bridge going across to put it into their accounting system. You know, what's the cost of this section and how long it's going to live. So they start breaking down life cycle costs of the bridge. And then part of that was, you know, obviously the life cycle of the pavement. You know, the whole bridge requires pavement to be repaid every 10 years based on the condition. So there's, when we go through and start looking at things, especially low bid, is it low bid? Is there a life cycle cost side of it? And then you look at service and reliability. Yeah, and I'm kind of, I'm already thinking about the other slide, but basically, you know, when you're looking at the life cycle cost, you also have to know what that asset is doing. What is it providing for service? You know. Okay, why don't we just jump into it? Okay, here we go.
If you're thinking about it, we'll go there.
I'm thinking about the okay, we'll go. Okay, here we are. We have an example of a new pump. We just bought a new pump. Okay, and then we go through and we look at what we have to do during the life of this pump. You know, so we say we got to replace the bearings and seals after 3 years. Okay, and what does it cost? You know, $2,500. Then we need to replace the couplings. Coupling will last 5 years. Okay, and then replace the shaft bearings. You know, 1,000. Recondition the check valve. Replace. All of a sudden, now you're starting to put all the costs of that pump together. What happens is people don't look at this when they buy that pump. They don't look and say, you know, this is what I have to put into my maintenance budget to maintain that pump. We just did a treatment plant, and typically after construction, they're filling things out and everything. The plant's been running for 3 years. All of a sudden, you know, you're kind of like off in the sunset. 5 years later, all the instruments and probes are hit their life, and all of a sudden they're hit with a $40,000 bill to replace the probes and lights because they weren't built in. The client didn't expect it, and typically it's not communicated. But when we think about putting specs together, we need to look at what costs are going to be occurring to the client. And I know that, you know, that's something that when we turn over, we kind of give them, you know, there's going to be these costs, maintenance costs, and just normal preventive maintenance that you're going to have to put into your budget. And it's a big hurdle for a lot of clients. So if they know that this is a 20-year pump, these are the costs that are going to occur during the life, that's the life cycle cost. And the best way to control life cycle cost is maximize the life of any asset. So if you can maintain it to the level of service that you want, then for it. Okay. Level of service. Level of service is either a system-wide level of service, like if you're doing a water system, our level of service is we promise not to poison you, you know. So in other words, we'll meet all the compliance and the regulatory, and we'll make sure that you have at least 35 PSI at your faucet, because that's the minimum requirement. Yeah, I would say that most of you guys don't have that because you wouldn't be happy with it. So that's not a very good level of service, you know. And then you have to start high, just burn right out. My head is that sugar. Okay, so when I look at level of service, I do two systems. I mean, I look at what I'm going to do, how quickly I'm going to respond. You know, if a pipe breaks, am I going to respond within a day? Am I going to get water back to them within 8 hours? You know, if I have a call, a service call, am I going to respond back within 4 hours? Whether it's good news or bad news, you know, is that the level of service? And these are system-wide level of service. At the same time, there's asset levels of service. In other words, when we look down in the air, they have a SCADA system that was not providing a proper level of service, but they spent this money on this SCADA system. They had it for like 4 or 5 years. We go through and we look, and it doesn't provide them what they need. So it's already failed, and that's an asset level of service. Heating systems, you know, have a certain level of service that you require. So you kind of look at different asset level of service. I know for transportation, I did up a document, striping. You know, for main arteries, you want striping to be visible, you know, at a certain level. But if it's a neighborhood, striping can be lower. If a bridge is critical to a school system or a hospital, it becomes a higher level of service that you want to maintain that bridge in. So these are the things that you look at. And it's usually a whole document. Then it's important to communicate with the level of service. Okay? You find that with snow plowing. Typically, you publish what your level of service is for snow plowing to the public, so they know what to expect. And a lot of times that is when it's snowing at a certain rate, we're able to plow all the roads every 3 to 4 hours. Okay, so you should see a plow truck go by once every 4 hours. Okay, now if it's snowing at 1 inch per hour, these are the roads that are maintained. So in other words, if you're on the cul-de-sac in the development, you might see a truck not for 8 hours. Okay, and then if it snows greater than that rate, you may not be plowed out until the end of the snowstorm. Okay, then which sidewalks are going to be plowed? Sidewalks close to the downtown and schools will be plowed out within a day. But here in the cul-de-sac, we don't plow your sidewalk. We just don't. That's the level of service to expect. Okay, so if you print that and you tell people what to expect, and that's the level of service you can provide, then it matches your budget, your staffing, and your equipment. So that's what you look at. When we talk about one of the things that we can utilize for consultants is when a contractor is out there doing work, when you go out to bid, you can develop what a level of service is that contractor needs to comply with. You will not have any of the people along that roadway without water for more than 8 hours. Or you will not block that road from two-way traffic or from the certain amount of time. Once that level of service is in the spec and the businesses know it and everybody knows it, there's less complaints about, oh, the contractor's not doing this, and if he's meeting with that level of service and those stores know what it is, it becomes a much more transparent process. So that's again how maybe engineers could utilize level of service. Okay. Risk. And of course, this is what we're going to cover in more detail, each one of these modules. So risk is really what asset management is. Now, and what you're looking at is if something's a low risk, and the reason why you have to manage with risk is because there's not adequate funding to maintain all the infrastructures that are out there. I mean, I don't know how many $1 billion in deficit in the gap analysis for what is needed to maintain all our infrastructure. So what do we do with the limited fundings that we have? We have to focus on the assets that are more critical. So you look at those, and those are where you develop your CIP. Now what do you do with the low risk assets? Well, you continue to maintain them. I mean, when we look at sewer pipes that, like we said, are 100 years old, or water pipes that are 100 years old, and if they're in a development that has low risk, and if it breaks, we can repair it within a day, and we can do it within budget. What do? You don't replace it. You let it run to failure. So now you have possibly 40 to 60% of your system that you can run to failure. And that's part of your plan. And when you do that, then you can say, we will only replace that asset when we're redoing the road. And it becomes much more economical to upgrade all the assets when the road's being reconstructed. So you try and tie things in together and develop. Otherwise, like we did Exeter, 80% of their system has already extended past its life. So they really had to reevaluate where they're going to focus. Okay? And then when you do priorities...
Thought you were ready to go.
Oh, no.
Go back?
Okay.
I can overcome.
I can skip it, because, I can see we're running over time already, because we haven't done it. Okay. Criticality is, if an asset fails, what is the impact? You know, is it environmental? I mean, if a sewer along the river fails and it goes and dumps right into the river, and right downstream a mile is a water plant sucking in the water, it's a high risk. You know, it's an environmental risk. That is a social, you know, because they'll be in the paper and they'll have your organization pretty well up in front. So you look to see if something fails, is there an environmental impact? You know, so then, you know, which could be an oil spill. You know, that would be an environmental. Okay. Economic. When you look at an asset, is it difficult to repair? You know, if you have a pipe that's 16 feet down, that's a higher risk and a higher financial repair if it occurs. But if it's, you know, down in Florida and the water pipe breaks, you know, you probably go out there with a hand shovel and dig it up, you know, and you're able to repair it. So you can look at the cost of repairing may impact what the criticality of that asset is. You know, and an asset could fail because it does not have capacity. If you have a pump station serving this area, and all of a sudden there's a whole new development that wants to come in, they can't come in because that pump station doesn't have the capacity to treat that. You don't have enough water capacity of your town to serve a new development that you may want. So there can be failures, but sometimes, again, you can look at the level of service and say, I don't want that growth, and that's how I'm controlling the growth. And then social, you know, social is when it comes up in front of the council. In Summersworth, we told them that the water pipes, basically they're 100 years old, they had no leaks, and the pipes were in good shape. But the risk of, once that project's done, and them having higher maintenance on that water system, it was going to increase. So socially, they did not want a project to be all buttoned up and then have a repair of their water line in their brand new project. So to them, that was going to be a black mark. So they decided to replace all the water system, which was probably a good thing. But again, it's part of doing the risk. Okay, you're up.
So,
Thanks.
you know, just to close it out, what it really is about is information. It's about how to get that information in a format you can make the best decisions. How do you communicate the information to the people that need to decide it? The goal, as John mentioned several times, is never enough money. So how do you make the best money, the best use of the money you do have? So as you budget, I had many projects when I walked in, and the slam dunk is, you know, the culvert under Mass Road, 20,000 cars a day, our entire economic core is going to shut down if this fails. So if you can weave that in your budget, you're going to have the best success. And then getting the different departments talking, that's what John was just talking about. If water, sewer, highway, everybody's looking at the same system, and you can overlap water, sewer needs with the pavement overlay, you get a higher chance of success. And then our goal, again, the people, process, quality, it's the circle again. And really, it's about evaluating the performance, delivering the best product to whoever's being served by it, and helping to project the most cost-effective maintenance of those long-term needs. We all design very expensive stuff. That's what we are in the business of doing. And our clients have to maintain that stuff, all with limited resources. So that's what it's about. It's all about helping them do things smarter and better. Helping them come up with a rate study that brings that risk in, being able to find their priorities, communicating. In a nutshell, that's what it is. A lot of moving parts. Every place, every system is going to be different. Very daunting. How do you scope it? How do you fund it? how you do it. Yes, sir.
How does Hoyle Tanner make money doing it?
That's the tricky part. That's where it's risky.
That's-
That's why Chris sat here.
I hear training, I hear, we're gonna train somebody, we're gonna do this, we're gonna do that, but I've also heard that, most of the time we prime something, and we're guilty of this as well, and then we sub out the collection, we sub out something else. Well, there's a lot, who wants to be the prime if we're getting 10% of the pie, and the 90% goes to whoever the workers are? So, are we gonna do the whole thing, or are we gonna just
Well,
be smart about it, train?
let me plant this as a seed to you all, because you all are the ones that are going to decide that. As we move forward, we got to find our own comfort level. We have to find what resources we have we can actually do it. Sometimes it makes more sense to hire somebody that does it every day. They got the equipment, they got the ability. We don't know the answer. As a matter of fact, what I know is every client's different, every setup's different, every place is different. So I think what we need to develop is, what are we really good at? What are we really smart at? And we need to plug the gap. John is very, very good at the high level. Once we know we got the system, he understands how those pieces fit together to develop like the high level system. But the IT stuff, that's not him. That's not what John's good at. So how do we fill that void? How do we walk in and look at, well, these are the kind of servers they have, this is their network, this is the GIS setup they've got. Somebody needs to be able to marry that to whatever system is going to work for them. And there's infinite number of systems to work with. Everybody's staring at my chest in it. I think the camera can be turned off at this point. We'll cut this part out. But as a team meeting, yes.
So I'm just curious, so do we have like a laundry list of things we can hand to a client? We can build this package to you and it will do X amount of things based on what they want, based on like price levels, or is it this kind of thing where we build the asset management package and we keep it in-house, but we do the system for them, or do we build a system and then hand it to them to run? Or
Did you see how Nicole jumped out of the chair when you said that?
Currently, there's no plan as to what can be done and covered because every client is at a different spot in their process.
Okay.
So it's a little bit harder to give them kind of a menu of things to choose from and say, I want red, yellow, and blue type of thing.
Right.
Because depending on their staff, depending on their system, depending on how many